dynamics. That is, the fluid is moving. Okay, Papa, unga peru? Merlin. Okay, Merlin. Akshaya. Okay. Vimal, and the papi peru? Manoj. Vellaichami. You are Vellaichami? Oh, right. I used to see doubts from you in online. Okay, fine. You are Vellaichami. I was searching for you actually. Right. So, right, where Pooja inge? Pooja. Right. Clear? So, fluid dynamics. Fluid dynamics na moving water. Moving water rendu vidama irukudhu. As we discussed already, moving water romba peaceful movement. Okay, peaceful movement. Okay, just like it is in this way. If we consider a passage like this, if I consider a point here, then the velocity of all the molecules under that point will be same velocity, VA. Ingo or water molecule irundha, its velocity also will be VA. Ellame VA. Suppose if we consider a point B, then all the water molecules here, okay, will be moving with the velocity VB. All the water molecules. Inge ella eduthu. So that is one assumption we are making while we study this. Okay, idukku enna per thangams? Streamline flow. Okay, very peaceful, systematic flow. So it is easy for us to study about this. When we assume like that, when we consider this kind of system, it is easy for us to study. Turbulent flow is there. Turbulent flow. So turbulent flow means, suppose if this is the passage, then full. Suppose if one tree is here, then the water will be making circular motion. There will be an omega, everything will be there. Okay, full messy. We don't study this. We are studying streamline flow. Okay, so again we will be making assumptions like this is incompressible. Okay, incompressible. They will be considering just an ideal fluid. Okay, then second one, no friction. Okay, we don't take viscosity now, which will come. Okay, no viscosity as of now. Okay, no change in density. Everywhere these all things will be considered as same. Okay, then only we will be studying this. Clear? The first topic in this is Bernoulli's theorem. Okay, so we will start with the Bernoulli's theorem. Okay, no, before Bernoulli's theorem we will discuss rate of flow. Okay, rate of flow. So here, from here we are starting our discussion. Okay, with these all assumptions, we are going to study continuity equation. Nothing but rate of flow. Rate of flow will be constant. Rate of flow will be constant everywhere in streamline flow. Rate of flow will be constant in streamline flow. What is rate of flow? Velocity?
With respect to time.
Velocity with respect to time. Acceleration.
Velocity with respect to area.
Velocity with respect to area. You can tell anything. Okay, this is our family. Namukkulla enna? Any answer? Sollalam, tappilla. Rate of flow enna? Volume of water crossing per second. Volume of water per unit time. Volume of water passing per unit time. That is what is rate of flow. Okay, so very important. Okay, all our discussion for some time will be completely on this. So rate of flow is equal to what? Sentence சொல்லும்போது volume of water passing per unit time நல்லா சொல்லும். Nothing but volume by time. Bas volume divided by time. Allava? So rate of flow will be constant. Rate of flow will be constant. See, paranga papas and poppies. Volume is what? Area into length. So இங்க என்ன போடலாம்? Time போடலாம். இப்போ வந்து this is இப்படி எழுதலாமா? Area into velocity. இந்த ஆள் வந்து volume. இவர் வந்து யார்? Velocity. So L by time, no. This thing we have replaced with the velocity. So that is what is continuity equation. Suppose if I consider this as first point and if I consider this as second point, then nothing but area of 1 into velocity of 1 will be area of 2 into velocity of 2. Very easy. இது பார்க்கும்போதே கொஞ்சம் நிம்மதி. We'll get peace seeing the continuity equation. Okay. இது மாதிரி ஒரு question வந்துச்சுன்னா we will be able to 4 marks. The whole world will score. A1 V1 is equal to A2 V2. Okay. Akshaya, fine, able to understand? Okay. Merlin, Velaichami, okay. So A1 V1 is equal to A2 V2. This is what is continuity equation. Clear? Okay children, so A1 V1 is equal to A2 V2. Suppose if we write A1 by A2 is equal to what? V2 by V1. So when A1 is more, this is equal, this equal to sign is there. So LHS and RHS must be equal. So if we increase this area, normally to make it equal, what should increase? V2 should increase. If V2 increase, what should happen to A2? Decrease. Then this one decrease. That is, this is the simple concept is, suppose inga oru chinna road, okay, inga oru periya road, periya passage, water is moving like this, where it will have more velocity? Here velocity will be more, here velocity will be less. This is what is the equation of continuity, the real meaning. Wherever small passage is there, water will gush through that. You are using equation of continuity very effectively. Do you have garden at home? What you will do? You will take the hose, amma adu on pannunga, what is there? The water is not very fast. What you will do? You will keep the finger there, you will reduce the area and right from the initial days, even when I was child, what I am doing, equation of continuity I am using. Okay, by reducing the area, increasing the velocity. That is what. Clear, children? Done. Okay, now we will do. You people are very fast, so we will do problems. Okay, so a small problem first. Get the answer. Consider this question like a vaccine. Okay, vaccine madri, to boost your confidence, giving one question. What is this velocity? Radius is equal to 2 millimeter. Vaccine, how vaccine works? We'll take very weak virus or weak bacteria. Okay, very weak strains we will take and we will inject into our body. We are not doing anything. Body itself is reacting. So body will learn about them. By attacking them, body will learn how to deal with these people. So even after that, very strong people come also, we will be able to deal. That is vaccine. So this is a vaccine question, simple question. What is the answer, children? Yeah, this one, A1 V1 is equal to A2 V2. So what is the area? R square, pi will be cancelled off. So R square 1 millimeter square into 2 is equal to 2 millimeter square into V. Millimeter square cancel. So this is how much? 2 by? Okay, so this is square, na? Okay, so 2 by 4, how much? Okay, 0.5 meter per second. Now do this question. I need to get the answer range. What is the range of this? Equation of continuity only, A1 V1 is equal to A2 V2. But how much you know about motion in a plane? Okay, that will be tested here. Just equation of continuity alone they won't ask. Need not ask, Leah. So they will put something else also, so that 2 chapter can be tested. Please do this. Hmm? 2 meters. Any other answer? Okay, so first we will start with the A1 V1 is equal to A2 V2. Okay, so area is what? Pi r square. So 4 millimeter. Okay, so let us take like this is going to be 4 square into V1 is 0.25. This is equal to there it is going to be 2 millimeter, so this is going to be 1 square into V2, correct or what? So V2 is going to be 16 into 0.25, 16 into 0.25, so 16 oda call 4 bus over, okay, 16 into 0.25, 16 oda call 4, okay, so 4 meter per second, this is the velocity. Now come here, what we need is range. Range is horizontal displacement or vertical displacement? Horizontal displacement. So horizontal displacement is equal to, is there any force in this direction? No. So no acceleration in this direction? Yes or no? You should tell me now. In this direction, is there any force? Gravitational force is there. In this direction, gravitational force is there? No. So no acceleration in this direction. If there is no acceleration, it is constant velocity motion, V is equal to S by T. So what we need to do? This is S is equal to V into T formula we can use. Horizontal velocity into time. This is what? Horizontal displacement. So horizontal velocity into time. Time ku vanda horizontal, vertical, everything is common. Correct or what? Right. So what is the horizontal velocity here? How this is gushing out initially? This will go in this direction first, then only F, G, everything will act. So initial direction of velocity is pakka horizontal. This is not kept like this. This is not kept like this. It is kept like this. So at this instant, here, initial velocity is pakka straight direction. Okay, so I could say this is nothing but what we are calculating for. 4 meter per second into time. Time is not there. Time is not there. But here 1.25 summa tarla. 1.25 is given for some purpose. So from here we will be able to find something. So this is horizontal displacement dane. Abdiya. Idanna displacement. Vertical displacement. So vertical displacement, right? Okay. So what we will write? Yes, y is equal to 1.25. Yes, edukku potirukudhu. Why I am putting S? To bring your thought to one dimensional motion. Normally we will be sitting relaxedly. Suddenly one song will be played somewhere when we were studying in school. Nostalgia will come, right? I need to bring you to motion in one dimension. So S is equal to ut plus half at square, S is equal to vt, something will come. That for that purpose. Okay. See children, this is nothing but vertical displacement. Vertical displacement. In vertical direction is a force. This is given. So acceleration due to gravity is there in the downward direction. So which equation we can use? SC is equal to SY is equal to UYT plus half AYT square. So 1.25. So here, is there any initial vertical velocity? No. Nothing is there. So I can put here 0. So this is nothing but half minus G dane, minus 10 into T square. Why minus? Because G is acting in this direction. So our convention, even if you are very strong, need not put minus also. You can have your own sign convention. It should be very strong. But here also minus I am putting. Okay. This direction minus. This direction minus. Upper positive, right positive, left negative. This is what we are following, right? Now we are getting 1.25. This will become 2.25. How much will be the T value if we take the square? 0.5. Now time is also ready. What is range? 0.5. So idu oda half. So 2 meters. So this is the answer. Clear? Clear? Okay children? Okay. Fine. Now so this was the thing. ஒரு சின்ன பையன் அங்கே ஓடி விளையாடிட்டு இருக்கும்போது he just saw something here, he just tried to catch it. So then I repair, I damage it, this came in this angle, okay, and it is given like this angle is theta, maybe 30 degree. Okay, now what will happen? What effect can come? What we have found, what is the velocity we got? 4 meter per second. 4 meter per second. So this 4 meter per second is in this direction. Okay, now suppose, say for example, in the question, the time taken for the particle to reach the ground, if they have given us 4 seconds. So this question is parvala, this is better compared to the one we have done in the class. That is what we will be thinking, Leah. Correct or what? So time is already given. They will be asking range. Okay, so this time range is what? Range is actually horizontal displacement. What we need is horizontal velocity into time. Horizontal velocity this time is nothing but 4 cos 30. So 4 into root 3 by 2. Okay, so we will have to do what? 4 root 3 by 2 into 4 total 8 root 3 meter. Clear? Done? Okay, copied this now. Shall I erase this? Wait, okay, note it down. Any Manavali? Clear? Done? Okay, clear? So all these varieties can be done, right? Okay, so from this any varieties can be done. Okay, see, suppose if it is kept like this, if it is kept like this, still we can do if this angle is given. Okay, so your basics in projectile, simple applications, only these kind of changes will be. This is what is physics. Okay, small changes are one question. So when you study something, just see all the possibilities. So all of you understood? Clear? Okay, fine. Okay, so put the heading Bernoulli's theorem. Okay, so Bernoulli's theorem, it says nothing but the sum of energy will be equal at every places. Okay, just like our energy conservation. Okay, the sum of mechanical energy will be equal every places, right? Sum of kinetic energy plus sum of potential energy will be equal. That we have already studied. Here one more thing will come, that is nothing but pressure energy. Pressure energy. So pressure energy plus kinetic energy plus potential energy will be constant. The sum of all these energies will be constant. This is what is Bernoulli's theorem. The sum of pressure energy plus kinetic energy plus potential energy will be constant. This is what is Bernoulli's theorem. Okay. So here pressure energy plus kinetic energy will be half mv1 square, okay, of this part plus mgh1. This is equal to the pressure energy plus half mv2 square plus mgh2. Now suppose if we do what is energy? Energy, work is what is converted into energy, right? Work is what is converted into energy. So what is work? F dot S. So when pressure is there, when pressure is acting on a particular area, what is force? PA. And this S is nothing but that length. So suppose if we consider for this area, how much length is covered, that is a volume. For this area, if we cover a length of L1, that is a volume. Same volume I will be getting with a larger area with a small length. Correct or what? So I am considering, we are analyzing the rate of flow. From this, finally what we'll be doing, most of we are dealing with the rate of flow only, the volume of water passing per unit time, or volume of water passing per second. So everywhere rate of flow will come. Okay, same volume will be passing through equal area, different area of cross section with the different velocities. Okay, so if we apply that in the pressure energy, we will be getting here, pressure energy is nothing but, what is that? A into L? Volume. So P1 into V, and here what we will be getting? P2 into V. So just by adjusting the area and length, okay, I will be maintaining equal volume. Ultimately what also will come? Velocity also will be adjusted and I will be getting equal volume. Okay, so this is what is pressure energy plus kinetic energy. Some other point, pressure energy plus kinetic energy plus potential energy. Clear? Now volume plus half into mass is what? Volume into density. So if we consider this volume, same V, if we are doing volume into density, okay, then V1 square plus, here again what I am doing, volume into density into H1. This is equal to P2 into V plus half into what? Volume into density V2 square plus. So here, okay, what is then mgh? So mgh is again volume into density into H2. Okay, volume into density into H2. So G is also there. G is also there. Is it clear? Should I write again? Okay. Shall I write here? Completed this part. Okay. So P1 into V plus V rho V1 square plus V rho H1 G. This is one side. Another point, if we consider P2V plus half volume into density into V2 square plus V rho H2 into G. Clear? Fine. So if I cancel this V volume everywhere, I can write in this way also. Pressure, okay, so this is nothing but pressure at one place plus kinetic energy at another place plus potential energy of another place will be equal to the remaining, whichever point we take, the sum of these three equal. So I could write like a P plus half rho V1 square plus rho GH, not V1, rho GH is equal to constant. Okay, so this is Bernoulli's theorem. Okay, so all of these variants which we are discussing are what? Bernoulli's theorem. Clear or what? Okay, children. Okay, now if it is at the same height, then pressure plus kinetic energy only we need to deal. If it is at the same height, what is the physical significance of this? What is the physical significance of this is, look here, pressure. What is this? Volume dane? Velocity, yeah. Volume illaya. Okay, velocity, volume mari pokudadu. Okay, so this is pressure and this is velocity. So pressure and velocity are directly proportional dane? Alla, inversely proportional. When pressure increases, velocity decreases. Okay, so if velocity is there, if the velocity is too much at some place, what will be the pressure there? Very less. You have seen yellow line near metro rail. You have gone to Chennai, right? So metro rail is there, metro trains. So yellow line is there. You should not stand there, but safely they have covered it also. Nothing should happen to us. That covering is there. Initially that covering was not there. Okay, so Delhi, that covering was already there, but now in Chennai also that covering is there. Suppose if covering is not there, yellow line is there, what happens if the train is moving at very fast velocity if it is moving very fast, the air molecules near to that train will be having very less pressure, because at that point, at that space, pressure will be very less. So எனக்கு எதுவும் வராது, எனக்கு நான் தைரியத்தோட சொரூபம், ஐ மீன் இன்கார்னேஷன் ஆஃப் bravery அப்படி சொல்லிட்டு இப்படி நின்றுச்சுன்னா what will happen? Pressure behind us will be more compared to this pressure. It will be just like someone is pushing us towards that. Okay, so very dangerous. Understood or what? That this is the pressure difference. That is the physical significance of Bernoulli's theorem. Those who are interested in cricket, okay, cricket. So how the swinging will happen, swinging of the balls. You have seen previously they used to do this. They rub the ball on the dress. What they are doing, they will smoothen one surface. One surface will be very smooth. So the velocities, if suppose if we are bowling, releasing the ball like this, if we are keeping the smooth surface this side, this side molecules will move very fast. So pressure will be less. So if the ball is moving like this, first the ball will be moving because of the force from the hands. We will be delivering like this, no? We will be delivering. The balls are delivered. Balls will be delivered in this way. It will be rotating like this. The seam will be rotating. So if one side is smooth, there the pressure will be less. So till some distance, the ball will move with the force which we have applied. After that, the ball will be completely moving because of the air. So what will happen? Here this is smooth surface, pressure is less. So which side ball will move? It will move this side. Pressure will be more here, pressure will be less here, ball. What is this? Outswing. Outswing. If you need to swing inside, keep the ball inside. Okay, then apply the ball like this, so that pressure will be more here, pressure will be less. So it will go inside. That is what is reverse swing alarm. You have seen reverse swing. No, in the air itself, ball will deflect into the stumps. Okay, this is how outswing, in-swing and out happens. But many of the conventional bowlers, what they do, they will turn the ball. They are actually pace bowling spinners. They will bowl like this, then after pitching, ball will be turning. That is different. What I am saying is swing bowling in air itself. Now the kind of balls that Shoaib Akhtar, Waqar Yunis and all, they used to, I think Brett Lee also. And Ajit Agarkar, Irfan Pathan and all from our team, they used to do this. Okay, so they used to do this. Okay, but people who can handle this surface, they know this physics also, actually. Clear or what? So this is the practical application of Bernoulli's theorem. We will start MRF coaching camp. You people can teach students how to bowl. Clear? Shall I erase this? Okay, if you have copied, just show me. Done? Shall I erase this, children? Okay, done. Erasing, okay? Okay. So now finally we can have this way also, P plus half rho is equal to constant. Suppose if something is happening like this, okay, so this height towards the center, if they are same, we can neglect this. Okay, suppose it's happening like this. Like this, almost the height towards the center, if they are same, you can avoid this rho gh. Okay, so fine. Now take this question, children. Okay, so here it is moving with 10 meter per second. Area is equal to 1 centimeter square. And another point, suppose if this is first point, if this is second point, here area is equal to 20 millimeter square. So that what the question is, what is the pressure difference between point 1 and 2? Pressure difference between 0.1 and density of fluid which is passing is also given 1200 kilogram per meter cube. Score എന്തായി തോറ്റോ ഡ്രോ Getting? Hmm. 144 into 10 power 4. 144 into 10 power 4. 144 is correct. 144 Pascal will come. Pascal is SI unit. I think somewhere some 10 raised to Jalka Bulka Dingle Mingle might have happened. Getting children? 144. So answer is like pressure at this point P1 plus half rho V1 square will be equal to pressure at this point P2 plus half rho V2 square. Now okay, area is given, no? Area is equal to, this is 1 centimeter square, this is 20 millimeter square. Okay, so the pressure difference between P1 and P2 is P1 minus P2 is equal to half rho V2 square minus half rho V1 square. So what can we do? Half rho if we take outside V1 square. So here V1 is given but V2 is not given. So equation of continuity we will have to apply. A1 V1 is equal to A2 V2. So V2 is nothing but A1 V1 divided by A2. So A1 is 1 into 10 raised to minus 4 into velocity is 10 divided by A2 is 20 millimeter square. So 20 into 10 raised to minus 6. Correct or what? Okay, 10 raised to minus 3. Its square is 10 raised to minus 6. So if you put about how much you are all getting? Hello? 50. Okay. So if this is 50 meter per second, then we can do. So this is half into 1200 into V2 square minus V1 square. So this is going to be 2500. Other one 10. So this is going to be 100. Okay, so this is 2400. So 144 kilopascal. Is it correct? 144 kilopascal. Allayo. 10 raised to varudha. Manam poch. ஓவரா பேசியிருக்க கூடாது. இங்க 10 raised to 4 okay, மன்னிச்சிடுங்க தேவன்பு. So this is to be how much, papas and papis? 4 4 Okay, right. Okay, so here height is same, right? Height is same, so we have avoided. Clear? So to find the pressure difference between 2 points, Bernoulli's theorem. Clear? I'm sorry. Okay children, shall I erase this? Completed? Nitish, able to understand? Okay, right. Suppose if kinetic head, okay, kinetic head of flowing fluid, kinetic head of flowing fluid, suppose if it is given like half v square by g. If kinetic head of a flowing fluid is half v square by g, then its dimension is L. Correct, no? Coming, you are getting L. Okay, so the answer is here L. Correct answer. Now suppose if we take P plus half rho v square plus rho g h if we do. Okay, rho g h if we do. This is equal to constant, correct? This is equal to constant. So this kinetic head, pressure head, kinetic head and potential head we will be getting if we divide this with rho g. If we divide this with rho g, we will be getting pressure head, kinetic head and potential head. They call them as pressure head, kinetic head and potential head. Okay, so we will be getting P by rho g plus this is going to be half into v square by g, and here it is going to be h. Okay, so what is the dimension of this? This is just a length, yeah. This is just a length, vertical length, that is height. So its dimension is going to be L. Obviously, definitely, this its unit, its units, its dimension, everything will be same. Okay, already I have mentioned this when we were taking the online classes. Okay, previous classes. Same way I am again repeating if someone is not remembering. SC is equal to UT plus half AT square. The unit of this is meter. The unit of this is meter per second into second plus, so second cancel. The cancel. So left hand side, right hand side, plus minus, between everything same unit, same dimension will come. When we multiply, anything can come. Okay, so remember, pressure head, kinetic energy head, potential energy head, everywhere the dimension will be what? L. Okay, remember this. Okay, and then take the handout part. Okay, go to question number 2. Oh, no need to do that. Okay, right. Oh, right. No. Okay, leave it. Okay, go to question number 9. A cubical block is floating in a liquid, right? Same question. Question number 9. Okay, a cubical block is floating in a cubical block is floating in a liquid with half of its volume immersed in liquid. When the whole system accelerates upward with an acceleration of g by 3, the fraction of volume immersed in the liquid will be. Question is, a cubical block is floating in a liquid with half of its volume immersed in the liquid. When the whole system accelerates upward with an acceleration of g by 3, the fraction of the volume immersed in the liquid. Clear or what? So till now we have discussed the cases like there is no acceleration, nothing. If it will be there, we will be putting something inside, that will be there. But now this time the acceleration part is also coming. Okay, can you try? So just I will be doing this parallelly. Okay, you just do on your own. Okay, after doing, just verify your answer. Okay, clear? So do on your own. Okay, just better please avoid looking at the solution. Try to think and do on your own. Okay, if you are getting the answer, good. Later you can see. This is moving upwardly, yeah? When the whole system accelerates upwards, right? A is equal to G by 3. Getting? What answer you are getting? So here y v rho L. So this is inside the water, Leah. Completely inside the water. So this volumes will be same. So into G effective is what? It is going upwards. So G plus G by 3 minus Vs rho S G is equal to Vs rho S G by 3. Or this is also G effective. This is G by 3. Fine. So getting, anyone getting the answer? What is the answer?
2 by 3.
No change in fraction. Anyone got no change in fraction between first one and second one? What is the question? A cubical block is floating in a liquid with half of its volume immersed in the liquid. Okay, with half of its volume immersed in the liquid. When the whole system accelerates upwards with an acceleration of G by 3, the fraction of the volume immersed in the liquid will be. So suppose we are considering X volume is inside the liquid in the first case, that is no acceleration, nothing. So X volume is inside the fluid. So how much will be the upthrust? Xv into rho L into G is equal to what? Its weight, mg. V into rho S into G. So the volume of inside we are getting as rho S by rho L. Clear? Now it is moving upward. When it is moving upward, just assume that YV is the volume inside. Okay, so U minus mg is equal to ma. Upthrust mg, the difference of this will be ma. Now U minus mg is equal to, this acceleration is given as G by 3. Now we are giving upthrust. So upthrust is nothing but the force acting upwards. So Y into this volume, okay, into density of the liquid, upthrust I am writing, and into G effective. G effective, because this time it is moving upwards. So simply if I need to write V rho G, I am writing G plus G by 3. So that I have adding here. Minus mg, Vs rho S G. Okay, minus. So I am getting like this. Now if you simplify this, we will be getting Y value. What you are getting? Y value. What Y value you are getting? Simplify this, we will be getting rho S by rho L itself. Rho S by rho L itself we will be getting. They have given half volume outside, half volume inside. But we have considered a general case. We have considered a general case. So if X is equal to rho S by rho L and Y is equal to rho S by rho L, that is, there is no change in the fraction. Even if it is moving upward with an acceleration, same fraction of volume inside and outside water we will be getting. I explain once again. First case, just assume that X part of the volume is inside the fluid. So U is equal to mg, U is equal to xv into rho L into G is equal to volume of the solid into density of the solid into G. I got X is equal to rho S by L. Second case, it is moving upward with an acceleration G by 3. I assume that Y volume is the volume inside the water. So again, this time U is acting upwards, mg is acting downward, the net acceleration is G by 3 upwards. So U minus mg is equal to mg by 3 I wrote. Now U is what? How much is inside? Y volume is inside. Y volume is inside into density of the liquid into G effective minus mg is equal to mg by 3. Now what I have done is I just put here effective acceleration. Then when I do this, I will be getting Y is equal to rho S by rho L. Oh?
Non-inertial frame. അപ്പോൾ pseudo force താഴോട്ടല്ല, a g by 3 താഴോട്ടല്ലേ വരും.
ഇതും കൂടി കൺസിഡർ ചെയ്തിട്ടാണ് നമ്മൾ ഇത് സ്യൂഡോ ഫോഴ്സ് ഇട്ട് ചെയ്താലും ശരി, സ്യൂഡോ ഫോഴ്സ് ഇടാതെ നെറ്റ് ആക്സലറേഷൻ എടുത്ത് ചെയ്താലും, ലിഫ്റ്റിൻ്റെ കേസിലും മറ്റേതിൻ്റെ ഈവൻ ഫ്ലൂയിഡ് മൂവിങ് അപ്വേർഡ്സ് എടുത്താലും ശരി, G+G/3 എടുക്കുക. ഒന്നുകൂടി ഒന്ന് എഴുതി നോക്ക്, കിട്ടും. Okay children, fine. So the thing is like whether it is in a static fluid, whether it is moving upwards with an acceleration, or whether it is at rest, we are doing the same thing. We will be getting the same fraction of the body inside the fluid and outside the fluid. Okay, so this is little difficult question, but the thing is we can generalize it. We can generalize it, so you can write it as a note under this, and you can remember, no need to do this if it comes for the exam. Means directly you can answer the question. Okay, so now you need to, after going home, just write this and see what answer you are getting. Okay, just work out on this. Okay, and if you have any trouble, you can ask. Okay, so please do some work on this. If you have any confusion, go to the law of flotation, look at the things and do. Okay, when it is floating, upward force and downward force are in equilibrium. Okay, consider that and do. Clear children? Right.